So I'm starting the third video for section 1.11 just on the answer key, and this is everything I've mentioned before. As you go back and look at everything, in order for something to be continuous, both the left side and the right side, that's what he means by pieces, especially in a piecewise function, so both sides, both pieces, must approach the same y value. Now he goes ahead and explains that he's going to call the y value b, because the second piece is the function must be defined and equal to that same y value b from the earlier problem. So if you think back to how I was explaining it, did all three pieces equal? If that answer is yes, then it is continuous. Now the jump discontinuity, as you're looking at this, the two sides, the left side and the right side, just have to equal different y values. That's the only way to jump, is if they magically go from a y value of 10 to a y value of 1. You have to jump between those two, and it doesn't matter if that function is defined or not, because even if it is defined and it equals one of these values, it doesn't equal all three. So that has to be a jump. So that's why we have this little asterisk here, star, I guess, to say it doesn't matter if f of a is defined or not. And then the point discontinuity, it's two of the three things are equal. And now it's specific which two things. If the left side is equal to the right side, so again, defines it as a b as the y value that's the same, but that y value cannot equal f of a, so what it's defined as. Now again, in a point discontinuity, f of a could be undefined, but this is definitely a different scenario than the continuous. So instead of me rewriting it, I just copied it over, pause the video, let this soak in, write it down in your notes. And I'm going to move on to the 4 examples we have. So as you look at the very first example, it is very clear that this problem is discontinuous right away. And now which discontinuity, I don't know yet. But we're going to examine at x equals -1, because that is where our bounds are for the left side of -1 and our right side. Now why am I saying it's discontinuous without doing any work? It's undefined. G of -1 is undefined, so if it's undefined, it can't be a continuous function. You definitely have to pick your pencil off the board and then put it back down. Now how do you figure out which one? And that's actually doing the math. So as x approaches -1 on the left side, g of x, which equation am I going to use? Well, the left side of -1 is the top equation. I'm plugging in -1 in there. I imagine you can do all this in your head, by the way, because -1 plus 4 is 3, squared is 9, -9 plus 3 is -6. So now do the same work with as x approaches -1 on the right side. So now the right side is greater than, plugging in -1 right there, -1 minus 3, then minus 10. So that's -4, absolute value makes it +4, minus 10 makes it -6. All right, well, it's discontinuous. Now we just have to say, are these two values the same? Since it is, this is a point discontinuity, or a hole. I forgot to write discontinuity, sorry. Point discontinuity at x equals -1. Context is everything in math, by the way. So I think we're ready for number 2. Again, feel free to pause and rewatch at any point. So where are we looking at this problem? We're looking at x equals -1. Now I can't just look at this and say it's discontinuous, because the function is defined. Now, as you're doing the functions defined, notice that it's the bottom equation. So as you do x approaches -1 on the right side of this function, you're also figuring out whatever this equals will also equal g of -1. So it will be defined, and it'll be the same value as the right side because it equals right here. So just to figure that out, -1 plus 3 is 2. 2 minus 4 is -2. So it's either going to be continuous or a jump discontinuity. Let me just change to different color. So you have to do as x approaches -1 on the left side now. And the left side is that top equation because it's less than. So -2 times the absolute value of -1 plus 3 plus 2. So -1 plus 3 is 2. Absolute value is 2 times -2 is -4 plus 2 equals -2. So as you look at it, the left side equals the right side, which equals the function at the point. That is, all three are the same. This is a continuous function. Continuous at x equals -1. And I don't want to get into another explanation. So number 2 is continuous at x equals -1. So we can also have problems that ask for continuities at more than one place. And the more practice you get, you can do this. So we can look at the discontinuity at x equals 3. And then we can also examine at x equals, let me just change colors, at x equals 5. So which functions do you need to look at for x equals 3? That's the top equation, because that's the left side. So I hate that this happens sometimes. My 3-year-old would tell me that we don't say hate as x approaches 3 on the left side. Now we're looking at h of x. 2 times 3 minus 3 obviously equals 3. As x approaches 3 on the right side, h of x is now 3 squared minus 2 times 3. So that's 9 minus 6 equals 3. And notice that this piece is also what x is. So h of 3 is also equal to 3. These two values have to be the same. So as you look at the left side equals the right side, which equals the function at the point, h is continuous at x equals 3. But that does not necessarily mean h is continuous at x equals 5. So now when we do as x approaches 5 from the right side, or sorry, left side, now which function are we looking at? It's the top one of the functions we care about. So the 5 is this one. That would be 5 squared minus 2 times 5. So we get 25 minus 10 is 15. As x approaches 5 from the right side, now we're looking at the bottom equation because that's the right side is greater than 5. So we're looking at 5 minus 3, absolute value of that, add 2. So 2 plus 2 is 4. Since this does not equal this, we don't care what h of 5 is. This is a jump discontinuity at x equals 5. So you can be continuous at one point, but then a discontinuity at another point. There we go. And then this last problem, please don't forget to pause if you need it. But this last one is fun, at least in my mind, because it makes you really understand the math. Because what we're trying to do is show that we have point discontinuities. Well, what needs to be true for point discontinuities is that the function on the left side needs to equal the function on the right side, but the function needs to be undefined there. Well, clearly at x equals -3, it's undefined. So all we have to do is plug in -3 in for this x and -3 in for this x and set them equal to each other. So we're looking at 2 times negative 3 plus 3 needs to equal negative 3a plus 3b. Now here's an issue, is we have 2 variables for one equation. So what we need to do next is look at another point discontinuity, and that's at x equals 2. And now what you're going to do is plug in 2 in for these x's. I'm going to write it right here, and then I can clean up both of them. So that would be 2a plus 3b needs to equal, now I'm plugging this 2 in for this, so 1/2 times 2 squared plus 3 times 2 minus 1. And so to make the point discontinuity is the left side has to equal the right side, and the function needs to not be defined there, and that's exactly what's happening. So now I can clean each equation up, like this blue one would give me negative 6 plus 3 is negative 3. And if I do this, the order of operation would be 4. Half of 4 is 2 plus 6 minus 1. What's that? 8, 7. So I get 7 is equal to 2a plus 3b. And I hope you remember doing systems of equations at some point where you can use elimination and get rid of these b's. So I'm looking at adding straight down as negative 10 equals negative 5a, or whatever method works for you, divide by negative 5, so a has to equal 2. But you're not done, because you need to go back and figure out what b has to be. And it's up to you which equation you use. Maybe just use the top equation. So that's negative 6, so I can add 6 over here. So 3 is equal to 3b, and divide by 3, and you get b equals 1. I hope you can agree with me that this is a fun problem once you get to it. So now you should be ready to work on your homework. Just as a heads up, you have a test coming up, so make sure that you are putting in the effort and reaching out to me if you have questions, either through email or in class.